Hello, today we continue solving a problem, and this type of problem is called a theoretical and practical output problem. And for this problem, I have chosen an interaction that leads to a very important substance. It is aspirin. Aspirin is derived from salicylic acid, which has formula C7H6O3, and acetic anhydride, which has formula C4H6O3. And the result is acetic acid C2H4O2 in addition to aspirin C9H8O4. According to the condition of the problem, from salicylic acid is taken to the salt within the framework of horseradish, and in the course of the reaction, the aspirin that results will have some of it lost due to the fact that aspirin is leached out by water, i.e., to get it extracted from this process. It can be dissolved in the water, and some of the aspirin may be lost. The solubility in this case of aspirin, it is important to know for the problem, is 0.25 hundredths of a gram per 100 milliliters of water. Then we will need to find what will be the practical yield of our aspirin due to this loss, due to the dissolution of aspirin in water. So how we will decide? So since we are given salicylic acid, we will sign 1 mole at the bottom. It follows from the coefficient, and let's find how much aspirin we will get according to the condition of the problem we have, and it will be the number of moles, but from the equation 1 mole. Now the first thing we will find how much we have salicylic acid in moles. So we divide the mass of the substance by the mass of the paint, which is 52.5 tenths of a gram, divided by the paint mass, and the paint mass of our salicylic acid is 138 grams divided by the moles, and then our substance of salicylic acid by the condition of the problem is 0.38 moles. 0.38 moles of this substance according to the problem condition. Then let's find how many moles of aspirin should be the theoretical yield. And accordingly, moles of aspirin, we will have respectively the same amount, that is 0.38 moles. And now let's calculate how much mass of our aspirin would be if there were no losses during solubility in water. For this, we multiply the mass of aspirin by the amount of aspirin substance, and it will be 0.38 mole. Multiplied by the mass of aspirin, which is 180 grams per mole. So we should have 68.5 grams of aspirin if there were no loss. But we are told that there is no loss because aspirin dissolves in water when it is extracted from this reaction mixture, and then we have to calculate how much aspirin is lost. And so then we use our given solubility value. It is lost 0.25 grams per 100 milliliters of water, and we have 900 milliliters of water. So let's calculate how much aspirin is lost. And this value will be 2.25 hundredths of a gram. That's the amount of aspirin that will be lost. But since it will be lost respectively, in the end we have less aspirin. Let's find out how much aspirin we actually have. Through this process, then to do this from a found mass of 68.5 grams, we take away the amount that is lost through water solubility, and we have 66.25 hundredths of a gram of this substance. That's our practical yield, which is a yield that's less than 100%. But then we have to find out how much is our yield of our aspirin that we're going to have in this calculation. And so in order to do that, we have a mass, which is the practical yield, divided by the mass of how much aspirin we should have gotten in the first place, and multiply by 100%. And as we understand in this case, we get 96.72% in the calculation. I would like to draw your attention to the fact that the practical output cannot be more than 100% respectively. It must always be less than 100%, and it cannot be large, otherwise the calculation is obviously made with an error. Therefore, as a test, you should see that your practical yield should always be less than 100%. So according to the condition of our given aspirin task, 96.72% will be obtained. We have such a task related to the necessary calculation for this medicine aspirin. I hope you liked. The task, it is quite relevant because losses in chemical industries are common, so it is important to learn how to take these losses into account, whatever they may be, in whatever ways these substances would not be lost. I hope that's clear. Goodbye.